Hello everyone and welcome back to the Kohi Game Engine series. Today we're going to tackle the final part of our shader system and integrate that with our material system. So before we jump into the video, I'd like to thank a few special people. We have the partners of the channel. Those are the highest tier of support through Patreon or YouTube memberships. And those partners are Caden, Eearslya, Joel, Kyla, and Wensheng. Also supporting the channel are all these other fine people on the screen. Thank you all very much for your support. It is greatly appreciated. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. Alright, so as I mentioned, we are in the final steps of our implementation today. So before we jump into the nitty-gritty details, I'd like to give just a quick outline of the overall changes that we've made. And I do want to point out that this is quite a massive change set, so I am not going to be able to review all of the code. And to illustrate just the size of how large this change is going to be, let's go ahead and take a quick look at the pull request that I'm actually going to be opening. And I'm going to go ahead and open this on video here because, as you can see, we're actually cutting it really close to the release time. This is probably the closest I've ever cut one of the videos in terms of close to release time. So I just wanted to make sure that it was as good as possible before pushing this out. But anyway, you can see here that we have 23 commits and a total of 37 files changed. Now, a couple of these things are just quick configuration changes, but we have a lot of changes here. And this is the entire refactor branch that we are working on, so all of these changes are not going to be covered in this video. I've already covered a lot of those changes, but we've also made some changes from even the changes that we've made in the last video. So just to give you guys sort of a scope of why we went ahead and did this on a separate feature branch. This is why, because it's a very big feature, and I wanted to make sure that it does not break the build while we're actually building it. So that is what the pull request is going to look like, and I will go ahead and fill this out, and that will be ready to go. Any of you guys that are out there that are sort of keeping an eye on this, you will probably see this pull request out there tonight. All right. So, a couple things that I want to cover. So we're in the final steps of our implementation, and we're going to go over the shader system itself, the actual system that is going to be stood up, and how that's going to be integrated with the material system. We're also going to review some of the other supporting changes that have been made. So one of the changes that is probably the largest change, even since the last video, is we have this new shader structure here. And this is renderer backend agnostic. So I've taken all of the stuff having to do with UBOs, any required alignment, memory alignment, that is, the stride, all of these different things, and I've moved them out of the backend. So now we have two levels of the shader system. We have this shader struct, which is the front end representation of the shader. So it has all these properties, and then it has a void pointer to an internal data. And that internal data is what the backend uses. So you all have seen this pattern before, we're just using it one more time here. So basically the way that this is set up, as I mentioned before, we have this shader for the front end, and then we still have our Vulkan shader for the back end. And the front end is primarily managing uniforms, attributes, offsets, things like that. And our Vulkan shader is now only going to handle the Vulkan specific logic, so the descriptors, things of that nature. And I've split that up just because the backend was doing a whole bunch of stuff that really shouldn't have been doing, and that stuff really belongs in the front end. It's front end logic. It's going to be logic that sort of translates between all the different various rendering APIs. So we've gone ahead and made that change. So this is what that looks like, and we'll dive a little bit more deeper into this once we get a little bit further into the video. Also added is a shader resource loader. So if we go here to resources, we now have a new shader loader here. And this shader loader is responsible for loading the configuration of a shader, which is one of the primary benefits of the shader system that we're creating. When I say configuration, we basically wind up with a shader configuration file. So it contains things like the attribute configuration, the uniform configuration, stages, whether we use local or instances or not, the names, file names, things like that. So what that is going to be loading is in our assets, we have these shader config files. So we have one for our material shader and one for our UI shader. So taking a look at this real quick, that's what one of these looks like. And this is going to make our system a lot more flexible and a little bit easier to update, because all we'll have to do for the most part is update this and update the shader. And then for known built-in types, we may have to make some small changes and small tweaks to code, and we'll jump into that later. But for the most part, setting up this configuration will be enough. So this configuration file basically looks like this. It has uses the pound symbol for comment lines. We have a version here, which doesn't really do anything right now, but if we need to ever have backward compatibility in the future, this is a way that we can support that. So right now we read the version in, we just don't do anything with it. We have the name of the material here, which is going to be called, in this case, shader built-in material. We have the name of the render pass that it will use. So this is configurable as well. And we have two built-in render passes right now. The render pass system itself is not dynamic yet, but we did add a little bit of code to be able to look that up by name instead of using an enumeration. So we can now configure this in the file as well. And that way when we add more, we can simply just reference it by name. We have the stages here, which is vertex and fragment. We have the stage files, which aligns with this array of stages here. So each one of these file entries is for one of these stages. So for vertex, we have shaders/builtin.shaderMaterial.vert.spv. So this is the path to the file that is loaded for that particular stage. You can see that we have the same thing here for fragment. Use instance and use local, we have these both set to 1. 1 is true, 0 is false. This may wind up being temporary, only because we can actually detect whether or not this is the case by looking further down in the configuration, but for right now, I wanted to leave it as is and have it be configurable. Next, we have our attribute configuration. So each attribute is on its own line, and it goes by type and then the name of the attribute. The type for this attribute is vector3, and it's called in position. The type for this one is vector2, and it is in text chord. So that is attributes. Uniforms is almost the exact same thing with one more field. So again, each uniform is on its own line. We have this time type, scope, and projection. And if you recall, we have 3 different scopes. So 0 means global, 1 means instance, and 2 means local. So we have our globals right here, which is 2 mat4s, 1 for projection, 1 for view. Those are both global. Then we have a vector4, which is a instance, and that is diffuse color. Then we have a sampler, which is also instance, and that is diffuse texture. And we have finally our local, which is the model matrix, which is a matrix 4, and that is marked as local. So we can very easily add or remove or change uniforms simply by editing this file. So we have that one, and we have the one here for the UI. And the only difference really here is the name of the shader as well as the name of the render pass, and then of course the type of the attribute, which is a vector2 for position instead of a vector3. So that is the configuration that gets loaded. So that gets loaded by our shader resource loader, and the shader resource loader eventually feeds that off to the shader system after it loads all of this into a shader configuration. Right, so the shader configuration is pretty straightforward. It's basically a mirror of that file. So I've tried to comment everything just so that you guys are fully aware of what all this different stuff does. So I'm not going to dive into any sort of deep detail here. Okay, so next for our shader system itself, the interface to this is actually pretty straightforward. One thing I do want to point out is we have made generic and moved the shader state. So this is no longer connected to Vulkan shaders. This is just a generic shader state of our not created, uninitialized, and initialized. Our shader uniform is much the same thing. It's just a shader uniform now, not a Vulkan shader uniform. Same for attribute. And then our shader here has an ID, a name, and then all of our properties that we set up before that have in the back end that have now been moved to the front end. And this includes things such as our uniform lookup. So none of that logic has really changed all that much. It's just been moved. Okay, so first thing we have is our initialize. It works just like an initialization for any other system. It takes in a memory requirement, optionally memory and configuration. It goes ahead and gathers that memory requirement, reports back on how much memory it needs, and then you can allocate that memory, pass it to memory, and so forth. The configuration itself is pretty self-explanatory too. It has a max shader count, which is how many shaders the system can handle. This should generally be at least 512, just because this also controls how large the hash table is. You generally don't want a hash table to have a small amount of entries because that can lead to easier collisions. So I actually did put a warning in there that if that's any less than 512, it goes ahead and bleats about it. So this is something that you probably will want to configure, and now it is fully configurable. Same thing goes for the max uniform count, max global textures, and max instance textures. Those were all to-do items before, now they are fully configurable. And that should cover it. Initialize, shutdown's pretty self-explanatory. The create is done here for shaders now, so it basically takes in a configuration, reads that configuration, and passes it then to the renderer backend, which stands up any resources that it needs to stand up, like the shader modules and all that kind of stuff. It's all the same logic that you've seen before, it's just in a different place now. And then everything else basically has to do with various properties of shaders or uniforms and things like that. So we have the ability to get a shader ID by the name of the shader. Same goes for, we can actually get a pointer to the shader by ID if we want. We can get a pointer to a shader by name. We can use a shader by name, or we can use a shader by ID. Now, obviously, any of these operations that you do by name has to hit the hash table to do a lookup. So generally what you do is you would get an ID or a pointer from that lookup operation, and you would store it off somewhere and then just use that going forward and not hit this every single time. Anyway, so we have our uses, then we have our uniform index, which basically takes a pointer to the shader to pull from or examine, and then the uniform name that you're looking for, and it potentially returns the internal index of that uniform for quick lookups. So again, you would want to store that off. Here we have a uniform set. You can set that uniform by name, and it just takes any sort of value. There's no size checking on this. And while I'm on this topic, I've gone ahead and I actually wound up removing all the individual functions that we had for all the various types, because it was just very repetitive. It was a lot of code, and it made the interface overly complex. So I've gone ahead and stripped all that out, and there's just one uniform set here by name. We also have the ability to set a sampler, works pretty much the same way. And then we also have the uniform set by index and sampler set by index. So if we go ahead and get the index of those, we can set that by the numeric, and it's much faster. We have our shader system apply global, which applies the global level uniforms. Same with instance. And then we also have the ability to bind an instance. So generally speaking, the way that this would work is I put notes in here where you would basically use a shader and then call one of these functions after the shader has been used, and it operates on the currently used shader. And that keeps us from having to pass the shader ID into every single one of these, because that's not really necessary. So it's just a little bit of a note there, and I've gone ahead and commented it accordingly. So that is the shader system in a nutshell. Most of the logic in the C file is stuff you guys have already seen before. So I'm really not going to step through this very much. It is pretty self-explanatory, I feel like, at this point. So for the sake of time, I'm going to go ahead and move on. So the other big change that I've made here is I talked a little bit in the last video about potentially collapsing the shader into the backend, into the Vulkan backend, because we had all these calls that were sort of piped through these multiple layers of abstraction, and that was just one more layer that we were having to call. And so I've gone ahead and done that, and the Vulkan shader has now been eliminated, and all of the shader functions have been moved directly into the backend. And this is probably a pattern that I'm going to continue a little bit going forward for a lot of our types, especially the more simple types, just to sort of reduce the amount of files that we have all over the place and kind of keep all the Vulkan stuff in one place. It's a little bit easier to manage, in my opinion, all in one file here. So I've started that. Likely I won't be doing most of that on camera, but I will mention it as I make updates to it in the future. So there is no longer a Vulkan shader.c. All of that logic has either been moved out and split off to the front end, or the back end Vulkan specific portions of that logic have now been moved to Vulkan backend.c. Okay, so that is a high-level overview of all the changes that have been made. There are a few changes that I've made to other parts of the system as well. Most notably, there are a couple of new string functions that I've added here just for a little bit of ease of use. So there's a string split function, which basically just takes in a string, a delimiter. It takes in a pointer to a array of character arrays, which is basically a pointer to a D array of strings. And we have options here to trim the entries, that is, remove any white space from either end of it, and then also include empty entries or not. And that has been super useful for the material shader config or the shader config files, specifically these comma-separated values here. So it's made that very easy to work with. One other update that has been made is to the material system, because I did mention that we are going to be updating the material system to utilize these changes to the shader system. So we have actually made updates to that as well. So the shader system has a few new functions added to it. So first off, our material config has changed a bit. The primary difference is instead of shader type, where we had this type of UI or world, that is gone. It now just takes a string of the shader name. So the configuration uses the shader name directly in the material. I already pointed that out in the file. And then the material itself no longer has a type. It has a shader ID. So that can be used as a quick lookup to grab the shader that the material is supposed to be using. And then the other benefit to doing it this way and not just having a pointer here is we can actually use this shader ID to group materials by the same shader and be able to sort lists of geometry by shader ID. And so that'll allow us to draw multiple pieces of geometry that use the same shader and not wind up having to do a whole bunch of uses all over the place. The shader system also is smart enough to keep track of what is the currently used shader. And if the current shader is already used, it does not reuse that shader in order to apply the next changes. So we're saving a little bit there as well. But anyways, back to the material system. So we've made that change to the material structure itself. So in the material system itself, we have three new functions. We have one to apply globals for a particular shader ID. So this is the shader ID that is associated with a particular material. This, generally speaking, will actually be using the built-in world or UI shader. And I'll show you in the render front end why we use shader ID here instead of material. But remember that the globals are instance agnostic, right? So every instance of the material shader is always going to have the same projection and same view matrix passed to it. So we only need to update that once. So this is the function that handles that. This applies the instance level material properties. So all we have to do now is pass a pointer to a material to it, and it just automatically maps that stuff inside, and we don't have to think about it. And then the global level kind of works the same way. So you pass a pointer to the material itself, and then a pointer to the model matrix in this case. And if we ever add anything else that needs to be handled locally, we can optionally add it here as well. So within the material itself, we have our apply global here, which calls our shader system uniform set by index. And this passes through a known index location for our projection, our view, depending on which shader we're actually winding up using. So we can see here that we actually switch on our known shader types here. And eventually, as we add more known types and we add a custom type, we'll be able to handle that logic in here. So that's the reason this is sort of scaffolded the way it is. So it applies either one of those things, or if it runs into a situation where it doesn't recognize the shader ID for some reason, it goes ahead and bleats about it. And then it goes ahead and calls shader system apply material. So we can do all of that by just calling this one method. Same thing goes for apply instance. So again, we just pass a pointer to a material. That binds the particular instance, right? So we're just using the internal ID of the material to bind that, just as before. It's just done here now instead. And then we check to see if the shader ID is the material shader ID or if it's the UI shader ID. And I'll show you in a second where that's set. Then we go ahead and set the shader system uniform by index. And again, we pass those known indexes. So in this case, we know about the index of all of these different uniforms, so we're able to keep track of those and use those and not have to look it up by string every single time. However, if we had something that was custom, we could certainly have the flexibility to look it up by name if we're just testing a new feature or something like that. We don't have to do it this way. This is just a much faster way for release, right? So we do still have the ability to go in there and look up uniforms by name. So here's where we set those, and then the apply local, of course, just calls the same thing again, just at the local level, using the locations that were saved. So where do these locations, where do these IDs come from? So when we first stand up the material system, we actually invalidate all these locations at first, right? So if we actually take a step back, our material system state has received a couple of smaller updates. So we have a structure for uniform locations for the material shader. Because this is a known built-in type of shader, we're able to do this. And that stores all of these locations here. So they're U16s. These are all the shader indexes that are used to perform quick uniform lookups. So we have the projection, view, diffuse color, diffuse texture, and model. And as we add fields to this, we'll just add them here and then load them down below, and then we can reference them and we're done. Here are the equivalents for the UI shader. Again, these are the same right now. That is not going to be true coming up shortly. So we have these two structures, and then we use them here and here. So we have material locations and UI locations, and then we also store the material shader ID and the UI shader ID. How do we get all this stuff? We know where it's stored. How do we get it? Well, when we are initializing the system, first off, we start off by invalidating all this stuff. We come down here, and all we do is we initialize our default material, which we may wind up wanting to save off an ID for the default material too. It's generally going to be 0, but we don't necessarily have to do that right now, so I haven't done that yet. But where we get that stuff is when we acquire a material from configuration, which, if you recall, that is triggered by the resource loader. So when we're actually looking to load up a material, we look for the material configuration, we load up that file, that gives us this config, and then we come in here and process it. So we've added a little bit of logic right below our load material to examine the properties of that material. So the first thing that we do is we get a pointer to the shader that is configured in the material, and that will actually be already set up by this load material. So load material will automatically make the mapping to a material that is configured in the material itself. So we have the shader name as part of the configuration that will get mapped to the material within load material. So we go ahead and get a pointer to that shader, and then we first check to see, is our material shader ID invalid ID, which is the default value for it. And if our config shader name is the built-in shader name material, which is this shader.builtin.material. If the name of the shader that this is using is that, then we can go ahead and grab these properties from it. All this does is saves off the shader ID and then saves off the indexes of all of these different uniforms. So here you can see where we're doing the lookup by name. So we look up projection, view, diffuse color, diffuse texture, and model. This extracts all of that from the shader configuration itself, gives us back those locations, and then we store them. So we do that once for the material shader and once for the UI shader. And any other shaders that we add can just be added to this list. We may go with something a little bit more dynamic in the future, but this is nice and simple to get us kind of up and running and give us something that's configurable and easy to update. So that is where all that information is fed in. Everything else in here is exactly the same. So how is this used in the front end? That's probably the last piece that we need to look at, because we understand on a high level how the back end is set up, but how is the front end actually making use of this stuff? So starting up here in the renderer system initialize, we actually have two critical init sections. And if you recall before, this was actually had a whole bunch of shader initialization code in it, and we don't have to do that stuff here anymore. All we have to do is load up the resource, which is, in this case, the resource name is the built-in shader name material, so that matches up with the file name. It is a resource type of shader, so we've added an entry in there for that. And that will give us a configuration resource. So we have that here. So what we do is we load up the configuration, which gives us a resource. The configuration here is extracted from the data pointer, which, if you recall, the resource data is just a void pointer. So that's a dynamic allocation, and it has dynamic allocations in it, but it's fine because this is just configuration. So we obtain the configuration here. We go ahead and create the system, passing along that configuration. If that fails for some reason, we bleat about it. And then we unload that resource, which goes ahead and frees all the resources having to do with that shader configuration, because we don't need it anymore. And then once that's done, we go ahead and store off the shader ID to the state pointer by just obtaining the shader system get ID by name. And we just take that same exact thing and do the same exact thing over for the UI shader. So this is our initialization code for our known built-in shader types. Any of our shaders that are of a known type are going to be loaded here, and then custom ones will handle a little bit different way down the road. Everything else in here is exactly the same. So this has actually made this section nice and tidy. So the other main change is to draw frame. So the draw frame basically has had its guts changed out. So instead of having to set uniforms and stuff manually in here, all we really have to do is first say, okay, we've started the render pass, the world render pass rather. Now we want to use the material shader, and we already have the ID for that, so we can use by ID. Next, all we have to do is call the material system and say, hey, apply the globals. Pass it the address of the state pointer projection and the address of the state pointer view. So we just pass those through as pointers, that way we're not copying all that data. And then we loop through the geometry just as before. We obtain a material from it, or the default material if it fails for some reason, or doesn't have one supplied or isn't loaded yet or what have you. Goes ahead and applies that. So we just call apply instance, passing the material, and it does all that for us. And then we go ahead and call apply local. Now again, these are separate steps right here. These eventually will be handled separately once we actually have the ability to group geometries by material, but we don't have that yet. So for right now, it's just done every single time. And then we go ahead and we draw the geometry, and then we just loop through that whole process for all the geometries. And then we end the render pass, and then we go through the exact same thing for the UI. So all the calls are pretty much the same. It's just the data that they're getting passed is a little bit different and being done against a different shader ID. And that is the majority of the changes for the renderer front end. Actually, that's pretty much all of it. One other thing to note is while we actually are standing up the built-in shaders within the renderer front end, we do not have to tear them down here because the shader system automatically handles that for us. So when the shader system gets shut down, see, it's going to be right here. All we do is we loop through all of our shaders, and any of those shaders that have something that's not an invalid ID, meaning there's a shader loaded there, it just calls shader destroy on it, which calls the backend shader destroy, releases all those resources so we don't have to worry about cleanup. When we shut down the engine, it just takes care of all that cleanup for us automatically. We don't have to worry about it. Okay, so with that said, I'm going to go ahead and clean, and we're going to go ahead and build and launch. And we can see here that we are in working order. So we can still swap our textures out, and all of that still works, updates as we would expect, and we can go ahead and shut down. And we're all back in good order and working. So I know that this has been a very high-level video. I know that I've skipped a lot of detail here, and part of that's on purpose, just for the sake of time. I want to make these as easily digestible as possible. So I encourage you guys to have a look at the pull request. The pull request itself will be merged tonight. However, I am going to leave the URL to the pull request in the description below. And that way you guys can actually pull that up and have a look at what all the changes are. Even though it's closed, you can still view it and get an idea of what all the changes are across the board. And you can see the individual commits and all that stuff. But like I said, 36 files, it's a large feature. It's far too much to go through all on one video and actually make any progress. So the next thing is we're going to actually leverage this to start making some graphical updates to the system. So we're going to be able to maybe start doing some additional texture maps and some lighting, that kind of stuff. And we also want to get loading some more interesting geometry than just the sort of planes that we've been working with. Get us a little bit something different to work with. So we are going to be leveraging these features coming up in the next couple videos. So thank you guys so much for watching. I hope you enjoy this series. I hope you are learning from it. If you like the video, please toss it a thumbs up. If you haven't already, consider subscribing. Click the little bell icon there to get notifications as to when new videos in this or other series drops. And I will see you guys next time.